To example 1.4.2, we are going to solve the following second-order linear homogeneous initial value problem. F double prime plus 5f prime plus 4f equals 0, with initial conditions f of 0 equals 0 and f prime of 0 equals minus 3. So let us begin by trying to solve the ODE part. We want to solve f double prime plus 5f prime plus 4f equals 0. This is a second-order linear, constant coefficient, and homogeneous ODE, so we should look for the characteristic equation. We read this off as lambda squared plus 5 lambda plus 4 equals 0. And now we want to solve the characteristic equation. So we look at this quadratic, and it's easy to factor, so we do that. We factor lambda squared plus 5 lambda plus 4 equals lambda plus 1 times lambda plus 4. And let's take a moment and check that I did the factoring correctly. I FOIL it out, lambda squared plus 4 lambda plus another lambda plus 4, and I get back lambda squared plus 5 lambda plus 4. Always remember to factor or solve your characteristic equation carefully, because if you do not, you will mess things up for everything else that is to come. But I factored correctly, so my solutions are lambda equals minus 4 and lambda equals minus 1. These are two distinct roots, so I'm going to look for a solution in the form f of x equals c1 times e to the minus 4x plus c2 times e to the minus x, where I will determine c1 and c2. As an aside, I promise that whenever you do these problems for homework or on exams, either the characteristic equation will be very easy to factor, or if it's not easy to factor, just go right into the quadratic formula and grind that away, and the arithmetic will be easy. Getting back to the problem at hand, I need to find c1 and c2, and let me make a remark on the side. I'm going to have to solve for f prime of 0 eventually, so let me calculate now, starting from f of x equals c1 e to the minus 4x plus c2 e to the minus x. Let me differentiate that, and I'll find that f prime of x equals minus 4c1 e to the minus 4x minus c2 e to the minus x. I'd much rather calculate that f prime now than have to do it when I'm plugging in 0 as well. And so now we're going to move to a new slide, just as if I were moving to a new board in a classroom. I need 0 to be equal to f prime of 0, 0 to be equal to f of 0, and that, of course, is c1 times e to the minus 4 times 0 plus c2 times e to the minus 0, which is just c1 plus c2. So I found one equation that c1 and c2 have to satisfy. And now I'm going to need minus 3 equals f prime of 0. And that, because I calculated f prime on the previous slide, is going to be minus 4 times c1 times e to the minus 4 times 0 minus c2 times e to the minus 0. So that becomes minus 4c1 minus c2. So I have two unknowns, c1 and c2. I have two equations. I feel pretty good about this. Let's put them together. c1 and c2 are going to satisfy c1 plus c2 equals 0, and minus 4c1 minus c2 equals minus 3. This is a linear system of equations for c1 and c2. I could solve this with matrices and vectors if I wanted to, and often I do that in the lecture notes when I'm doing theory or it gets hard. But here I can just do a direct substitution. I start with c1 plus c2 equals 0. I solve for c1 equals minus c2. I put that into the next equation. Minus 3 is originally minus 4c1 minus c2, and that's minus 4 times minus c2 minus c2, 4c2 minus c2, 3c2. So I'm left with 3c2 equals minus 3, and therefore c2 equals minus 1, and so c1 is minus c2, and that's 1. And then going back to my form of f on the previous slide, I know f of x is c1 e to the minus 4x plus c2 e to the minus x. So f of x is e to the minus 4x minus e to the minus x. And that, I claim, is my solution, indeed my only solution to this initial value problem. And of course, I can check my work by plugging the formula for f back into the differential equation and taking derivatives. And I can also check my initial conditions just by plugging in 0 for x here and making sure that everything checks out. And I encourage you to do that because there are plenty of places here where your arithmetic or your calculus could get a little messed up and the solution is off by something.